Hi! As a supplement to the tutorial of GAIN GUI, this video will walk you through the parameter selection process of the GUI. We suggest you watch the general tutorial before playing this video. As we mentioned in the general tutorial, although the default parameter values are good enough in most cases, we may still want to adjust them based on specific requirements. The GUI's parameter selection process is created to meet this demand. You can adjust the parameter values either by typing a number or dragging the slider. The range of a slider is 0 to 10 unless otherwise indicated. This range includes most values that may be used. However, you can still type values outside this range in the edit boxes. If you have a question about any of the parameters, you can always find help messages by moving your mouse above the parameter names. Now let's start to look into the parameters in detail. The first parameter, bright nuclei selectivity, is a threshold factor used for nuclei segmentation by Otsu's method. It's fine to include some really small objects that can't be real nuclei, since they can be removed later. Let's try the default value first. If we make the value higher, we will segment fewer nuclei. This is obviously not a good choice. If we want to segment more nuclei, we simply make the parameter value lower. However, this time many nuclei clump together to become huge nuclei. Therefore, we know we need a value in between. Now we get better segmentation. It's okay to have some dim objects not be identified, since the next step will capture them. GAIN allows us to skip some steps. If you want to see if a parameter can be skipped, you can check the pop-up message of each parameter. For example, to skip the first step, you can type INF in the edit box. No change has been applied to the figure. Note that the slider becomes unavailable since we choose a value beyond its range, but it can resume its function once we change the value back. The second parameter, dim nuclei selectivity, is a second threshold factor used to adjust the previous segmentation. Its function is to identify the dim nuclei lost in the first step. If we make the value too high, we'll fail to identify some nuclei. However, if we make it too low, some nuclei will be clustered together. To avoid that, we need to raise the parameter a little bit. The next parameter specifies the radius of the disk used during morphological opening to separate weakly connected nucleus objects. This parameter must be a positive integer. When the value is low, only a few changes will be applied to the figure. However, if we want to split some loosely connected nuclei, we can apply a higher value. You can also set this parameter 1 to skip this step. The next parameter is a threshold that separates clustered nuclei from non-clustered nuclei. This parameter must be positive and less than or equal to 1. Note that the range of this parameter is 0 to 1, not 0 to 10. Here the default value does a good job to find nuclei clusters. Suppose we want to obtain more clusters. Simply raise the value. On the other hand, lowering the value results in fewer clusters. Let's change it back to its optimal value. This parameter adjusts the typical nucleus area used to calculate nucleus counts. A low parameter value results in a high nuclei count for each identified cluster. For example, here, this cluster has 23 nuclei. If we raise the value, the nuclei count for each cluster will decrease. This same cluster now only has 14. The next parameter will be multiplied by the typical nucleus area to determine the minimum size of a valid nucleus. If it's low, more nuclei will be regarded as too small to be a true nucleus. If we make it higher, fewer nuclei would be regarded as too small to be a true nucleus. This next parameter is a threshold factor used for cell body segmentation by Otsu's method. Starting from this step, the parameters only affect the cell body's image, but not the nuclei image. If we use a high value, we'll include fewer pixels as part of cell bodies. On the other hand, if we use a low value, we'll include more pixels as part of cell bodies. We don't need to care much about the neurites at this stage. The point is to identify cell bodies as accurately as possible, without capturing too many neurites. You can set this parameter to INF to skip this step. The cell body neurite discrimination parameter controls the size of the disk used to isolate cell bodies from neurites. This parameter must be a positive integer. The goal at this stage is to separate cell bodies from everything else. We choose a low value, we'll remove fewer neurites. We can see that the neurites are not cleaned up. Some of them remain on the figure and are identified as cell bodies. A low value will also result in narrow neurites later during neurite segmentation. Selecting a high value will remove more neurites. A higher value will also result in wider neurites later during neurite segmentation. You can also set this parameter to 1 to skip this step. The neurite selectivity parameter is a threshold factor used solely for neurite segmentation by Otsu's method. The purpose of this step is to identify neurites as accurately as possible. Selecting a low value results in lots of pixels being as parts of neurites. As you can see, we have too much noise. Selecting a higher value causes fewer pixels to be parts of neurites. As you can see, we failed to identify some of the neurites. With an adjusted parameter value, GAIN identifies most neurites without including too much noise. You can also set this parameter to infinity to skip this step. The secondary neurite selectivity parameter is the second threshold factor used solely for neurite segmentation by edge detection. Selecting a low value results in capturing lots of additional neurites. It may also include some irrelevant parts. On the other hand, selecting a high value captures fewer additional neurites. We can call this good enough. You can also set this parameter to INF to skip this step. The last parameter indicates the side length of a square used to join nearby neurite sections by morphological closing. This parameter must be a positive integer. The purpose is to further refine the neurite segmentation. Selecting a low value results in small gaps between neurites being bridged. On the other hand, selecting a high value causes larger gaps between neurites to be bridged. You can also set this parameter to 1 to skip this step. Thank you for watching this video. If you have any further questions, please find our PDF document or contact us. We also welcome any feedback for the improvement of our software.